In this presentation I'm going to talk about volume rendering. Volume rendering is available under modality 3D mode. These three are the hanging protocols that have a grid item that supports volume rendering. So I've selected big 3D volume, and here is the grid item with the volume rendering. With the right click we get this menu where we have the options of the different rendering modes. The first one is the maximum intensity projection mode, which is the one we're currently looking at. This one will give us the value of the voxel with the highest intensity amongst all the voxels that are traced from our eyes towards the screen and through the volume. Next one is a minimum intensity projection. This will give us the one with the minimum value. Of course, because there is air, because there is surrounding air, it's not possible to see much. But use the cut planes, and it's possible to see all the air structures inside. I'll talk about the cut planes further on. Third one is the average. The operation of the first three modes is affected by the current windowing levels, so changing that will affect the end result here, as you can see. The fourth and the fifth one on the ray casting modes. This one is without any lighting, and this one with lighting calculations. I'll talk about later how to change the display of this, how to change the transfer function and what do they mean. There is a surface mode. Will give you an isosurface, that is a surface that goes through all the points that cross a certain threshold, which is user defined. The photorealistic mode, the photorealistic mode is effectively a surface mode, but with a lot more visual cues. So all the depth differences and all the edges are darkened. There is an orthogonal view, which will follow the location of the crosshairs. Let's talk about what the first line of commands does. Switch back to MIP. This is the camera mode. As I'm dragging my mouse cursor around, I can change the position of the camera. So if I drag and do horizontal, it will rotate vertically. If I do drag vertically, it will rotate like that, and so on. So with consecutive rotations, it's possible to get my camera anywhere I want. The second one will move the light, but this is only relevant in surface mode when we have selected the follow light. There's a zoom. There's a point and click that will take us to the position under the mouse cursor. You can see here how the position of the crosshair has changed to follow the hand. These are the cut modes. Let me switch back to MIP so it's easier to see. In the cut mode, it will generate a cut plane that's perpendicular to the camera. It's centered around the crosshairs. So I move the camera now around. I can see that the cut plane, which cuts through the volume, is always perpendicular. I can so it's the position of the crosshair is here, and I can see all the space, all the volume around it. The cut plane will behave differently under this mode. Will cut through the volume and will show you what's beyond the cut plane, and it will assume there is air from the position of the cut plane and towards you. So this is a toggle, so I can turn it on and off. This one, the select arbitrary orthogonal perpendicular cut planes, will assume that there are 6 cut planes, on 2 for the axial, 2 for coronal, and 2 for sagittal domains, and I can move them each independently. This is how this would look in MIP. So the 2 cut planes are there. I can do the same by dragging and pressing the Alt key. So these ones on the coronal, sagittal, and axial domains. The play buttons have the functionality of animation, so this one will just rotate the data sets, and the rest will do so as we've explained before. I will rotate once, rotate ping pong, where it will go once clockwise and once anti-clockwise, and so on. There are a number of options here from the horizontal toolbar. The first one is how the camera moves. So all axes will have the typical quaternion camera. The axial, for example, will only rotate the object around an axial axis. See, coronal, sagittal. The free one is quite interesting. Let's put that mode on. With the free, it's possible to roam inside the dataset. So my camera is now following there. I control the direction of the camera using my mouse, and I press the keys Q and A to move forwards or backwards. So super sampling levels would change the amount of detail that's available. The times 0.5 makes the rendering much faster, while the times 4 will delay rendering, but it will generate much more detailed images. So this is the difference between the two. Use the times 4 if you have a very powerful machine. The fast preview, if it's off, it will not subsample, so it will make things a little bit slower for viewing. I normally keep it on. This is for linking 3D cameras in hanging protocols where you have more than one volume rendering grid items. This one is quite interesting, but I'm going to talk about it a bit later, because I first have to talk to you about intensity thresholds. The textured cut planes, if set to on, and if you have a cut plane, will project the slice of the original data on that cut plane. So here now I have 2 sagittal cut planes, and the information from the original data is projected upon them. Let me remove the cut planes. light position of whether it's on camera or arbitrary. Cut planes will follow crosshair position. This will generate cut planes that will follow the position of the crosshair. So as I move up, the cut plane is following the axial domain. Here it's probably easier to see if I put the texture cut planes on there. Turn it off. This will cast shadows on surface mode. Just add another visual depth cue, so it's on by default, and this is the animation speed. Now, if I reset this,